Nicola Cairo, Project Officer at ETN Global, and also Communication and Dissemination Work Package Leader for the Robinson project. Today, we're delighted to welcome you to the last and sixth training module of the Robinson project, where we started in January 2024, and today we are finishing with a dedicated cybersecurity module with our project partner, Óscar Ansótegui Adarve, pardon, from FUNDITEC, our Spanish partner, based in Madrid, and also leading the activities of cybersecurity over the last 3 years um, of the activities. So Oscar is an experienced researcher in cybersecurity and blockchain, and he joined recently our project partner working specifically on Robinson project. So with this, I am happy to give the floor to Oscar for his presentation. Please be aware that after his presentation, we'll dedicate some time for question and answers. And we hope this training module will be useful for enriching your expertise in islands decarbonization. Thank you. And Oscar, the floor is yours. Thank you.
Thank you, Nicolo. Hi, everyone. Let me share the screen. Start. Okay. Yeah, so hi, everyone. My name, as Nicolo said, is Oscar. I'm a blockchain and cybersecurity researcher in FUNDITEC, and I will guide you through this training session on mainly how blockchain technology can ensure this data integrity and availability that we need in the energy management system in Robinson. So let's explore how these secure and useful data solutions can drive innovation and also reliability in this green energy transition. Okay. So first of all, I think we all know this Robinson project and what is it about, but if there's someone who isn't directly involved, you're more than welcome. And first, let me sum it up in one sentence. So Robinson is mainly about creating these flexible, secure, and efficient energy systems for industrialized islands powered by renewable energy, innovative storage, and also cutting-edge technologies and digital solutions like the EMS. But having this said, there's a key question that is how can we ensure that the data feeding this system is secure, reliable, and traceable? So that's the question that we from FUNDITEC were trying to answer during these 3 years. Our mission has been to strengthen the foundations of the EMS, ensuring that the whole set of data that is processed is not only secure, but also transparent and trustworthy. And yeah, these efforts are critical to ensure that the EMS remains resilient against threats while delivering transparent and reliable energy management. So let's dive a bit deeper on how cybersecurity and blockchain can play a key role in achieving this. First of all, yes, to introduce some cybersecurity basics, say that the EMS, we know that is the beating heart of operations in this project. It collects, it processes, and optimizes energy in real time, enabling efficient energy management across the whole system. However, this constant flow of data introduces some vulnerabilities that our team couldn't ignore. and then some critical questions raised. For example, what happens if the data in these transmissions is intercepted or manipulated, or what happens if some unauthorized user gains access to critical systems or lead to modify any data or logs directly from the production. And yeah, just to say that these are not just hypothetical risks, they represent real threats to the integrity and trust that the EMS provides, and that we have to focus on address these vulnerabilities and propose solid and robust systems that can address and give solution to this. So we implemented a cybersecurity strategy that is mainly based in a methodology that is called PASTA, which stands for Process Attack Simulation Threats Analysis. Yes, and this is an advanced risk-centric framework that is designed to analyze and mitigate cybersecurity threats. And yeah, this methodology has helped our team to identify potential attack scenarios, such as the ones I mentioned in the slide before, and the impact they can have in the energy management system. So through this methodology, we determined that one of the most effective ways to mitigate some of the key risks was to integrate blockchain technology into the EMS. Why? Because this technology provides immutability. This means that data, once it's recorded in blockchain, it cannot be altered. Transparency, meaning that all stakeholders can verify the integrity of energy data independently. And then also access control, which means that with these blockchain cryptographic mechanisms, we can ensure that only authorized users can interact with this sensitive data. So by combining this, first, the PASTA methodology with this proactive risk assessment and the inherent security and traceability that blockchain provides, we've built a system that can defend against these threats and also enhance trust and collaboration among different stakeholders. Then, before we dive in what blockchain is and how it works, first we have to take a step back and talk about some fundamentals, um, which are the building blocks of blockchain. Um, First of all, we have to talk about cryptography. One of the most powerful cryptographic tools that blockchain has is this public key encryption. That is a mechanism where you have a dual key operation. You have one public key, which is like a mailbox, for example, that anyone can encrypt data and send this data to this mailbox. And then there is the private key, that is something that only one owner has and is unique. And with that key, it can open that mailbox, ensuring that only this authorized person or recipient can access the information. So data in the energy management system is encrypted using a public key. Um, and only the private key that is held by each stakeholder can decrypt and access this information. So this guarantees that we have this confidentiality and authenticity in the whole system. Also, another building block of this blockchain mechanism is the hashing process, um, which is the process of converting data into a fixed length digital fingerprint. No matter how large or small the input is, the output of the hashing function will always remain the same length. And yeah, let's break this down a little bit. Seeing this diagram, we have data here in the left part It can be any kind of file, log, or even a string. Um, this is put into the hashing process, which is cryptographic algorithm that generates a unique hash value. And this algorithm is unidirectional, meaning that you cannot reverse the output. So from the input, you can get the output, but you will never get the input out of the output. So this makes it ideal for verifying data without revealing the sensitive information. So let's see this in action. I have here, wait. I have this online tool that is not developed by us, but it gives a perfect example of what I'm saying. For example, imagine that we're using here this algorithm of encryption that is SHA-256, and we give an input, which can be, for example, Robinson, and we get this fixed length output, which is a combination of characters, numeric and alphanumeric. Um, and if we change just a single byte of the input, the output is totally different, not even similar. So everything each change in the input will change the output. And for example, if we get the example with a production log of an energy plant, this is mock data, this is not real, but it can give us an example. If someone, so for example, if we have this file with this information, this will be the output after hashing. But if we come here, for example, and change this data 400 to maybe 200, the output will be totally different. So with this, you will always know that data has been manipulated. So let me get back to the presentation. Okay, so for example, now let's say we have a file. So the idea of this is that we put this file as an input of the hashing function, and then we store this hash in some kind of database that will remain immutable. I will explain this later because this is one of the key characteristics of blockchain. But for now, just imagine that we have this ledger with this database that cannot be modified or altered. Okay, and now we get the same file and store it in a normal database, in a traditional database, and we store there our original document. Now, let's say that we continue our lives normally, and then after a few months, an auditor wants to check the integrity of the files and the documents. So it will take the original file from this traditional database from here, and will apply again the hashing function. And now it has the hash inside the immutable register and the hash that has been applied from this input. And now if this auditor compares these two hashes, if the comparison is exactly the same, it means that this original document stored in this database has not been tampered or modified. But if the comparison is not the same, it will mean that someone has manipulated the data in this database. So yeah, this is the idea of what we are building in Robinson. And these are the cryptographic principles that foundate the basics of blockchain technology to ensure that every block in this chain is secure and verified and tamper-proof. And now let's see how we leverage these mechanisms in Robinson. First of all, let's take a closer look to this blockchain architecture. Yes, this diagram provides a clear overview of blockchain works. First of all, here at the top, we see that the blockchain itself is, as the name says, is a chain of blocks, which each block contains data, a unique hash, and the hash of the previous block, meaning that each block on the chain is linked to the previous block, and this ensures that if any block is modified, the information is modified, the chain will be broken. And immediately noticing that there's an issue and the data integrity could be compromised. So this creates an immutable ledger where data cannot be altered with detection. And also there are some mechanisms that mainly are this part of the diagram that ensures that this data modification is almost impossible. So first of all, let's see how transactions are processed. When you want to, for saying this, write information in the blockchain, you have to execute or send a transaction. First of all, you sign that transaction with your private key, introducing the key principles of public key encryption that I talked before. And this ensures that the transaction is authenticated from the original user. And then there are several types of transactions, like for example, tokens and cryptocurrencies, which we are not using in this project. Um, Also smart contracts, which is the way of interacting with the chain that we are using here in Robinson. That a smart contract is like a self-executing code with preset conditions, and there are also other ways. So when you have this transaction, you send it to the chain, which basically is a set of different computers that are interconnected and decentralized. So the transaction is broadcasted to this decentralized network of nodes, which each node has a complete copy of the ledger on top. So each node would, with the public key, verify the transaction and validate its authenticity. And then also there's a thing called consensus that the nodes work together to reach consensus on the validity of this transaction. So once it's verified, the transaction will be sent to the blockchain and added to the next block, meaning this that blockchain will be decentralized, immutable, and transparent. So now knowing how blockchain works, this is the architecture that we have built in Robinson for the EMS. And this diagram illustrates the decisions we've made to ensure scalability, security, and efficiency. The first decision was to choose the blockchain we were trying to build, because there are many types of blockchains. There are public blockchains, which are open to anyone, but come with higher energy cost, slower transaction speed, and also limited control over participants, but are also more decentralized. Some examples of public blockchains can be, for example, Bitcoin or Ethereum. And then there are private blockchains that are more controlled. So there is less decentralization, but you have faster transactions, better energy cost and efficiency. So our choice was to build consortium blockchain, which is something that balance decentralization with control, and this ensures that only trusted participants like Robinson consortium members can interact with the system and maintaining this efficiency. So we chose this technology, that is Cosmos software development kit that helps us build a modular and scalable design, enabling this interoperability with customizable modules to meet specific needs in Robinson. And then also we have the smart contracts, which are modular and are the way we, as I mentioned before, write information and retrieve information from the blockchain, and also automate some other processes. And then we deployed everything in Amazon Web Services in Elastic Cloud Computing. And we built a set of APIs to ensure that the EMS interact with blockchain easily. So now let's dive and explore how this technology can be applied and is really applied in Robinson to enhance the security, transparency, and efficiency. Um, it's important to note that our approach integrates blockchain without altering the energy data, ensuring the system remains fully aligned with the project requirements. So this is the flow of data in blockchain. First of all, we collect this data, which comes from the different IoT sensors, such as production or consumption rates, energy output logs, and things like that. Then we hash this information and store it in the ledger by these cryptographic algorithms that I mentioned before. So this will ensure the integrity and the privacy, and then you can always validate. It's validated with the different nodes of the chain, and it can be also auditable by different stakeholders, such as project partners, regulators that can access the blockchain and verify at all time the integrity. Okay, so with this, we have the key benefits that I've been mentioned in the whole presentation, highlighting that data remains unaltered in the EMS and can be at all time audited. Now I will present a bit the work that we've done in Robinson with a small demonstration. Um, just to recap, we our contribution to the project has been to have this proactive threat management using technologies such as PASTA methodology, ensuring that the vulnerabilities are addressed before they come real threats, and then building this blockchain system to ensure at all time stakeholder trust, transparency, and data integrity. So um, I will stop sharing for a second while I prepare the other part of the presentation. Okay, so can you see my screen again? Yeah,
Yes,
right.
Oscar.
Okay, so here this might be a bit more technical, but I will try to go really slow so that everyone can understand. Here in this part of the screen, we will generate mock data. So for now, imagine that this will be the output of an energy plant that has like different energy production logs that will be generated each time. So for example, just an example, if we execute this, some logs are being generated all time that have like this mock data. This is not real data, it's something that we made up for the presentation. But all this information is being recorded in this folder. Okay. So now let me reset this for a second. Now, here in this part of the screen, we have this script that we made to talk to the blockchain and save the hash of these files into the blockchain. So if we execute this and execute this at the same time, for each file generated here, we're adding it to the blockchain. Okay. So now, for example, we can stop this. We generated 3 files here that appear also here, and we have them here, if you can see them. And they are all being added to the blockchain. So now we built this front end that is our verification system that can ensure these properties that we highlight here, the verification and traceability of data in an instant result. So we have this element here to verify the integrity of any file. So imagine now that I'm an auditor and I want to verify the integrity of this first file here, ending in 40, that we also have it here. So I will just drag and drop it here. So it's uploaded there. And if I try to verify the integrity, it says that the file it exists in blockchain and that the file matches the blockchain record. And here we have the hash algorithm of this file, and it says that the integrity is verified successfully. But what happens now if, for example, this same file ending in 40 that we also have it here, I I changed something. For example, um, this this data here, I don't know, I change it to anything, and I add some, imagine error log or something here. Okay. Now, if this same file ending in 40 that previously I showed that the integrity was verified successfully. If I try to verify it again, now it says that it still exists in blockchain, a file with that name, but the file has been modified from its original state, highlighting that someone has changed the data in the database and that the file integrity has failed. Okay. And now also another thing, imagine that we stop this, so we're not recording data in blockchain for the moment, and we generate another another file, which is this one. So if we add in our system a file that is not in the blockchain, the system will detect it and say that this file doesn't exist in blockchain. But for example, if now we execute this saver again and talk to the blockchain again, it will say that now it is added to the blockchain. And if we try to verify again, it will say that the file exists and the integrity matches successfully. So as you can see, it's a dynamic process that auditors can at all time check and verify the integrity of all records, of all energy logs and outputs of the production systems. Okay, so let me get back to the presentation now. Okay, so now let's talk a bit about some broader application that this blockchain technology can have, especially in this energy sector, that its potentials extend far beyond this project. Like the same principles of this transparency, immutability, and decentralization can be applied to also other industries and application. And let's see some of these broader applications. First of all, imagine a future where some individuals and businesses can trade this excess of energy production. Imagine some people that have energy panels at home and want to trade the excess of production with maybe some neighbors or other stakeholders. These blockchain systems with this set of smart contracts could ensure that these transactions are secure, transparent, and automated. Um, Also, this blockchain technology can be used to ensure sustainability with mechanisms to emit carbon credit tracking or some certificates to provide this tamper-proof record, helping organizations and governments to track emissions and ensure that all partners maybe meet these sustainability targets. And also this another application could be managing supply chains for renewable energy infrastructure, and that not only making the traceability of energy but also different maybe elements such as solar panels, wind turbines, and other elements, making, for example, digital product passports of each piece and ensuring uh, that the efficiency and the output of every element is improving efficiently, ensuring authenticity and reducing all frauds. So now let's sum up a bit the lessons learned. This has been a groundbreaking project, not only in this energy management system, but also on how we have applied some advanced technologies like blockchain and cybersecurity and how they can transform complex systems. So first of all, I want to say that cybersecurity is something that is not negotiable. Uh, it's very important to protect these critical systems like the energy management systems, and that it requires some proactive methodologies like PASTA methodologies to identify and mitigate threats even before they occur. So that's how we've ensured this reliability of Robinson data flow. Also, it's important to enhance trust and transparency, and blockchain is key in this. By integrating this blockchain technology, we've created an immutable and auditable system that has enabled all stakeholders to verify this integrity independently and in improving trust. Also, scalability and interoperability. The selection of blockchain technology such as Cosmos that I mentioned before, that is really, it's very modular, scalable, and interoperable, is key. This can adapt to our future needs and help us integrate this technical part that we've built with further blockchain networks or even other technologies. So it's really important when you build a system to always think in this scalability and interoperability, and also to say that this data privacy and integrity can coexist, and that our approach to keeping this original data intact while leveraging blockchain for traceability has ensured compliance with different regulations, as we're not storing in blockchain um, the whole energy output, which could maybe not comply with some European regulations, but this dual framework where we only store the hash and then the rest we store it in a traditional database will always ensure that at some point we can always like forget about this data and start again. Yeah. So that's it. As we look at the lessons learned, we can also highlight the importance of collaboration, innovation, and adaptability, and that together we can lead the way of building smarter and safer systems with these transparent ways. And thank you for being part of the journey. And if you have any questions, I'm here to answer them.
Thank you, Oscar, for your work, for your availability to present today what you did for Robinson in terms of cybersecurity. And I appreciate the level of detail that you presented at today's training module. Uh, so the um, before I start opening the question and answers session, I remind you that I just opened a Slido survey where I can ask all our participants if they want to share with us their feedback to our webinar. The purpose of improving the quality where appropriate for future training modules in Robinson and also other projects. So with this, whilst you are going to complete our surveys when you want, I open the floor for the questions or remarks you may have to Oscar's presentation. You can also uh, chat when you want. If if there is no question, I would like to ask you a question, Oscar, because I
Yeah, sure.
was looking at the last slide of your presentation, correct? And you were focusing on the scalability and interoperability of the system as such. And with Robinson now, we are focusing both on the demonstration sites in multiple locations, right? So in Norway, as you said, in Scotland, and also in Greece, with the future aim of replicating the system. So my question is, what are your view the main challenges when it comes to the upscale of this system for future projects? What would be your suggestions for any other project representatives that are attending today?
Um, yeah, so it's something that has to be addressed properly because, um, for example, if you load too much data in a blockchain with the size of a private blockchain, it can easily like saturate the network. Um, but always you can scale the system. For example, we are deploying everything in Amazon Web Services, which we could even scale more um, with higher virtual machines and everything. So we would have to study it in detail, but I think there won't be any problems in it reaching higher scales with this blockchain system.
Thank you, Oscar. So that was a detailed answer. So hopefully this will also help our attendees who went through similar experiences in their projects, either EU or private. Is there any questions from our audience? You can
I will
also, yeah, please.
I will leave my email in the chat in case anyone wants ask something later, I will try to answer as good as possible.
Thank you, Oscar. Yes, please, Alfredo, I see your raised hand. Welcome to the meeting. I think you're muted, Alfredo.
Sorry. I would like to ask a question related to the performance. Considering in this case of a system, energy management system, we receive a huge amount of data from telemetries and other kind of system. We are receiving continuous data. I think the problem is the performance, because how you can ensure that all the data you are receiving are encrypted, informed, and timely in the blockchain, and you are ensuring the immutability and other characteristics. So, in my opinion, when you receive a huge amount of data, the challenge is the performance. I don't know if Oscar agree with this consideration or not.
Yes, this having like huge amount of data leads us to think more about the architecture and maybe upscale it with more nodes so that each transaction can be processed not only by small amount of nodes, but many more, so that the process will be even faster. So this is something that we have to think from the design and to think about how many transactions we will send to the blockchain, and then build the blockchain accordingly to the amount of data that we want to record. But also say that, for example, if we produce a whole set of data, but we are just writing on the blockchain a small fingerprint of this data, we could also like record data, not single files, for example, but batches or set of files which can be encrypted in the whole set, and then just write on blockchain one single fingerprint or hash, which can also optimize the system. But yes, your question is something really important that when designing a blockchain architecture, you always have to think, because it's important to ensure this efficiency in operations. And yeah, but there are ways to ensure that the system will work properly.
Okay, thank you. So another question is related to the consumption of energy.
BPR layer on.
Sorry? I don't know if someone wants to ask anything, or it's my turn.
No, please, Alfredo, please go ahead.
So the another question is, considering that one of the goals of this project is try to achieve a full decarbonization of the island or geographical isolated areas, if we need a lot of energy to in the process of encryption to include the element of the blockchain, how can we can achieve this goal? In other words, if we want to reduce the consumption of energy or try to cover the demand using renewable energy, if we use a lot of energy to the process of encryption and to include the data into the blockchain, I think we have to achieve a balance among these two objectives. I don't know if you understand the question, but I think there are two objectives in contract, because as I said, the idea is to try to achieve a full decarbonization of the island. In other parts, we have to use a huge amount of energy in the process of encryption and including this information into the blockchain.
Okay, yeah, I understand your question, because this energy consumption is something that is always being discussed in this blockchain industry. But I have to highlight that there's a huge difference between public blockchains such as Bitcoin or Ethereum that have huge energy consumption rates, and consortium blockchains that are in slower scales. That, for example, each stakeholder of the consortium can have one node that will be like a computer that can be in cloud or in a physical server or whatever, and the energy consumption is not that high. You can always say that you're still wasting or using energy, but also you have to put that in balance and see if you want these benefits of blockchain technology, or you don't want to have them. But also say that if you're not using this system and you are using another system built with traditional databases or things like that, you will also consume energy. So you have to do a study, and just let me share a graph that I wanted to show. For example, this is a bit blurred, but I think it's good for now. This is a graph comparing energy consumption of different blockchains. This one is Bitcoin, that the energy consumption is per transaction would be in scale as the Burj Khalifa building. And then Ethereum, for example, would be the Tower of Pisa in this power of proof of work consensus mechanism. But now they changed to a proof of stake consensus mechanism, and the energy would be as a little screw. So if you see Bitcoin, it always alarms everyone because it has a lot of energy consumption, but there are modern blockchain technologies that are adapting to lower energy consumption rates. And these are still public blockchains. Ethereum has thousands and thousands of nodes. In our system, in Robinson, we would have just the minimal amount of nodes to ensure the security in the chain, and that every stakeholder can access the chain. So it would be even smaller than this one. So just to put it in scale, that we're not consuming that much energy, although we are consuming energy, but like um, maybe a bit more energy than if we build a traditional system with normal databases. But yeah, it's a good question, because it's something that is always being discussed in this blockchain sector, and we definitely have to take into account.
Okay, thank you very much, Oscar. Thank you,
You're
Nicole.
welcome, Alfredo.
Thank you, Alfredo, for your enthusiasm and interest in the presentation of Oscar. I think we still have a few minutes for another question.
Det er meg som sitter i mørket. Bare kom inn.
Oh.
Ta den litt opp.
Please, if anybody has any questions or remarks, we still have a few minutes.
If not, you're more than welcome to write me on my email and have a chat and answer your question.
Yes, exactly. That is that could be a good approach. So Oscar has already shared his email. So in case you do not have any further questions or remarks for this meeting, I propose we close this last training module, and we intend to thank you for your constant participation this year at our training modules. also in particular also for this one today. And we again thank Óscar and FUNDITEC for their participation availability to make it for today. And for any further questions you may have in the future, please feel free to reach Óscar. Thank you, and we wish you a good day.